Hi everyone. Today's lesson is going to be a review and practice of the two methods that we've learned to solve systems of equations, graphing and substitution. And remember, substitution involves equal values method as well. So we're going to do a few of these together in this video lesson, and then you will finish up this worksheet for homework and submit it online. Okay? All right, so the first thing we're going to do with number one is we're going to graph those two lines. Okay, I'm going to make this bigger so I can zero in on the graph. Both the equations are already in slope-intercept form. So if you look at these two equations, they're both already set equal to y. So that's good. So if I, let me take that away. If I write down the m and the b, the slope and the y-intercept, then I can graph it. So on the first line, my m is the coefficient of x, which is 2, and the b is the number at the end, which is positive 5. And then on my second line, I'm going to change up colors here. My m, I have negative x. So remember, when you don't see a number in front, it is a 1. So the slope is actually negative 1. It's a negative slope. And it's really negative 1 over 1. And b is positive 2. Okay. So when we go to graph that, let's graph the first line. We always start at the y-intercept at positive 5. So count up on your y-axis to 1, 2, 3, 4, 5 and put your first point. And then this tells us to go up to right 1. Up to right 1. And I want to get some on the other side so I can make a nice long line to see where these intersect, because right now I don't know where they intersect. So I'm going to do that down to left 1. So I get a nice straight line, and hopefully that should be enough to see our intersection point. Okay, now I'm going to graph the red line. My y-intercept is positive 2. 1, 2 on the y-axis. And this slope is negative. It's going down. So it's going down 1, right 1. Down 1, right 1. And if I keep going in this direction, I'm obviously not going to intersect, so I need to go in the other direction. Up 1, left 1. Up 1, left 1. And you can see we just intersected there. So I'll draw that. And remember, your solution is where they intersect. What is the ordered pair? Well, the ordered pair, so our intersection point is right here. So that would be negative 1, 3. And that's our solution. Okay. All right, now we're going to move over to the right-hand side, and we're going to do the same exact problem, except this time we're going to do the substitution method. Okay. The substitution method with this one, both lines are already set equal to y, so this one is actually the equal values method. When they're both set equal to y, you set them both equal to each other. So I'm going to take this part right here and set it equal to this part right here. And now I just solve for x. I'm going to get my x's on one side. Those cancel out. Bring everything else down. And my numbers on the other side. I'll subtract 5. 2 minus 5 is negative 3. Divide both sides by 3, and I get x equals negative 1. Okay, so I compare that over to my graph on the left. Yep, x was negative 1. That's right here. And they match. That's good. They should. They're the same problem. Okay, now let's go back in and find y. So I'm going to plug in y. I'm going to plug in my x value of negative 1 to find y. So I'm going to use the top equation. 2 times negative 1 plus 5 is negative 2 plus 5, which is 3. So y equals 3. And again, over here, y does equal 3. It's right there, so those match. Those two match. So again, I put my ordered pair as the final answer. Negative 1, 3. Okay, so the left side matches the right side for our solutions. All right, very good. Let's do another one together. Let's jump down to number 3. Let's graph it first. Now, the thing is with number 3, if you look at our two equations, one is set equal to y, which is good. This one right here, this one's ready to go. I can graph that one right away. However, this equation is not. This one is not set equal to y. So in order to graph it using the slope and the y-intercept, we have to turn that around and solve for y. And this was our lesson from last week. So in my white space here, I'm going to start with my equation, x minus 3y equals 21. And my goal is to get y by itself. So the first step is always get your x to the other side. So it's positive. I'm going to subtract it. Those cancel out. Drop down negative 3y. Keep these two terms on the right separate. Bring your x term out front and your constant last. Okay. At this point, we have to divide out our coefficient of negative 3. And you have to do that all 3 times for each term that we see. And we end up with y, oops, sorry about that, y equals, now, negative x over negative 3 doesn't really make sense. Put in a 1 here. You can really see that fraction now. It's really negative 1 over negative 3. A negative divided by a negative is a positive, so we just leave it as a fraction, attach your x. 21 divided by negative 3 is negative 7. Okay, there's our two equations right there. So let's go ahead and graph that one in red since we're already in red. Our y-intercept is negative 7 right here. So I'm going to go down on the y-axis to 1, 2, 3, 4, 5, 6, 7 and put my point. And my slope is 1 over 3. It's a positive slope. So I'm going to go up 1, right 3. Up 1, right 3. Up 1, right 3. I'm going to get one more on the other side just to make sure. Down 1, left 3. And make my line. Okay. I'm going to do the other one in blue, this equation right here. It's already in slope-intercept form. My y-intercept is positive 7. So I go up to 7. 1, 2, 3, 4, 5, 6, 7. And my slope is 5 over 1. So up 5, right 1, well, I'm going to run out of room on my graph, so I can't do that. So I'm going to go down 5, left 1. 1, 2, 3, 4, 5, left 1. 1, 2, 3, 4, 5, left 1. 1, 2, 3, 4, 5, left 1, and we just intersected. Perfect. It's a very steep line. Okay, so where did we intersect at? We intersected right here at this point, which is negative 3 all the way down to negative 8. And that's our ordered pair solution. Okay. All right, good. Now let's go ahead. I'm going to clear that out here. And move to the right, and we're going to solve the same problem, but this time we're going to use the substitution method. All right, so what I see here is I can use that original equation even though it's not in slope-intercept form. And what I'm going to do is I'm going to take this value of y. The value of y is highlighted here. Well, I can use that value of y to plug into the y of the other equation. So what I do, I'm going to change my color. I'm going to circle this value of y and plug it into y of the other equation. Okay? So when I bring that up, I'm going to write it down as x minus 3 times the value of y. Well, the value of y is 5x plus 7. So since it's two terms, I need the distributive property. And then I finish the equation with equals 21. Now I'm ready to distribute, combine like terms, and solve. So I have x negative 3 times 5x is negative 15x. And then negative 3 times positive 7 is a negative 21. Now I'm going to combine like terms right here. X, which is 1x, 1 minus 15 is negative 14x, minus 21 equals 21. And now I'm ready to add 21 to the right-hand side. 21 and 21 is 42. Divide by negative 14. Those cancel out. X equals negative 3. And again, that matches my negative 3 on the left-hand side over here, so that's good. Now I got to plug it back in to make sure my y is correct. So I'm going to plug it into the second equation where it's y equals. So y equals 5 times the x value of negative 3, which is negative 15 plus 7, which is negative 8. And that's y equals. Okay, so again, my final solution is negative 3, negative 8. I'm going to write that. I'll put it somewhere over here. Negative 3, negative 8. And that's my final answer on the right. And of course they match on the left because it's the same problem, just two different ways to do it. Okay. If at any time I'm going too fast, just pause the video so you can write down all your notes. All right, let's do one more on the back together. Oops. Okay, we have two equations. Let's do number 6. We have two equations here. It looks like neither of them are in slope-intercept form, so we're going to have to turn those around. I got to put them in slope-intercept form so I can graph them. So I'm going to start with 3x plus y equals 6. That one will be pretty easy. 3x plus y equals 6. I need to get y by itself, so I'm going to subtract 3x to the other side. Now I just keep my x terms separate. And now I'm in slope-intercept form. I didn't have to do anything else. I don't have a coefficient of y that I'm dividing out. So I'm done on that one. So this one is good. Put a little check mark there. All right, I'm going to switch out colors. Let's do red, Christmas colors. All right, now we got to turn around 4x plus 5y equals negative 25. First step, get your x term to the other side. It's positive, so we're going to subtract it. Keep the x term separate out front. And now we're ready to divide every single term by 5. 3 times. Those cancel out. I get y equals, this is my fraction here, negative 4 over 5. That's my slope. Attach my x. Negative 25 divided by a positive 5 is a negative 5. So now I have my second equation. Let's go ahead and graph that one first. Back to my graph over here. All right, so on the red line equation, my y-intercept is negative 5. So count down, 1, 2, 3, 4 to negative 5 right there. My slope is down 4, right 5. This is a negative slope. Down 4, right 5. Okay, and then it looks like we're going to run out of room on that side, so I'm going to do one on the other side. So I'll do the opposite. Up 4, left 5. I'm going to do one more just in case. Up 4, left 5. Now I know I'll be able to see what happens there. Oops, kind of missed my points. Let's try that again. Still didn't do that great, but that's okay. That's a little better. All right, now we are going to graph our green line, which is y equals negative 3x plus 6. So our y-intercept is here at positive 6. 1, 2, 3, 4, 5, 6. This is a negative slope. It's a negative 3 over 1. So it's down 3, right 1. Down 3, 2, 3, right 1. down, 3, right 1. I got to keep going till I intersect. 1, 2, 3, right 1. 1, 2, 3, right 1, and there we are. There's our intersecting point. Okay, so now I just need the ordered pair of where those intersect, which is right here. Let's see, so our ordered pair would be 1, 2, 3, 4, 5, 5 over. And how many down? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a negative 9. And that is our solution. Okay? All right, good. Now let's move to the right and do it with the substitution method. The substitution method requires at least one of the lines to be set equal to x or y. So since we already put them in slope-intercept form, we can use either one. I would prefer the one without the fractions. So why don't we use our green line here? Y equals negative 3x plus 6. And then we'll use the other one in its original form. Okay, so what I'm going to do, I'm going to use this y equals, since I know the value of y is this, y is negative 3x plus 6, I can plug it into the y of the next equation. Okay, so I take that second equation and I'll do 4x plus 5 times the value of y, which is negative 3x plus 6, distributive property, equals negative 25. Now it's time to distribute, combine like terms, and solve. So I have 4x plus 5 times negative 3 is negative 15x. I'm going to take out that plus and put in a minus 15x. And then 5 times positive 6 is positive 30. And write down the rest. Combine like terms right here. 4 minus 15 would be negative 11x plus 30 equals negative 25. And subtract that 30 to the other side. A negative 25 minus 30, you're going to add those together and keep them negative. So that would be a negative 55. And now divide out your negative 11 coefficient. X equals positive 5. Is that what we got on the left side? Yep, sure is. Perfect. Now we just need to plug it back into one of the two equations and make sure our y matches. So I think what I'll do is plug it into that first original equation. 3 times 5 plus y equals 6. 15 plus y equals 6. And then subtract it to the other side. 6 minus 15 is negative 9. Perfect. It matches. Okay, so x is 5, y is negative 9. I'll write that again as my ordered pair for my final answer. It's 5, negative 9 in parentheses. And that's my solution. Okay. All right, very good. So remember, you also have the possibility of getting parallel lines or the same line. Remember, if you end up with the same line, it means it is all solutions. It's an infinity. Or if you end up with parallel lines, that means they will never intersect, and that would be a no solution. Okay, so be on the lookout for those. So there are 1, 2, 3, 4, 5 problems left that I'm going to have you guys finish up for your homework, and that will be due tomorrow at 8 a.m. or by 8 a.m. Okay, when school starts. All right, if you have any questions, email me anytime, and I will see you guys, soon. We're going to have a project for next week, and I'll definitely get a Google Meets in there so we can talk about the project for next week. Okay? But again, if you need me, email me, and I'll talk to you soon. Thanks. Bye.